Right. So I would like us to continue or remind ourselves of what we discussed last week. So, who have a clue of what we talked about last week? If anyone has a clue, the person can unmute and talk. What did you do last Friday? What did you do on Friday? Sorry, what did you do on Friday? The last meeting we held.
Okay. Please, I remember you take us through some of the tools and then the interface, and also the difference between AutoCAD and then the AutoCAD Inventor, where you said with the Inventor, parts of a machine or whatever you are drawing, you can do it in parts and then later on assemble them. That makes the AutoCAD Inventor different from the AutoCAD itself. And then you clarify us on the interface that I mentioned metric box and said it's the grid. We call it the grid. So we also look at some of the tools. This is what I actually remember. Yeah.
Yes. Right. Okay. Sorry for that. Okay. So I think that's basically the summary of what we did on Friday. That's basically the summary of what we did on Friday. We talked about the interface, and we talked about the main tools we use in mechanical designs, and we talked about the difference between the AutoCAD and the Inventor. I think I didn't introduce you guys to the SolidWorks, which let me try and open it. Okay, let me try and open the software for you guys so that we can all also see the interface of the SolidWorks 2. So let me share my screen. All right, please, can you all see my screen? Can you all see my screens? Please, can you all see my screen? Right, thank you very much. Okay, so this is basically the interface of the SolidWorks, right? This SolidWorks is not like the Inventor and the other ones we see. This one is different. It's different. It's different from the Inventor. It's different from the AutoCAD app and other stuff. So this is basically the interface of the SolidWorks. You see, it's very simple like that. It has so many menus and so many stuffs. It has so many of them. I think let me try and open. You see, it's almost the same as the Inventor. You see, with the Inventor, we have the parts, we have the drawing, we have the assembly, and we have the presentation. But with the SolidWorks, we have the parts, we have the assembly, and we have what? The drawing. So it is also an advantage for the Inventor as well. Because I think most people now uses the Inventor, often uses the Inventor. There's AutoCAD. I think the AutoCAD is very suitable for 2D works because of its easy approach or easy commands it has, right? It is very suitable for 2D drawings. You can make 2D drawings very easily and fast using the AutoCAD app. Looking at how the app, the software looks like. You see, you just pick any tool, you do what, you start drawing. The moment you do what, you enter or you log into the interface of the AutoCAD, it is basically 2D stuffs, right? So this in the Autodesk is good for 2D drawings. That's one of the advantage of the AutoCAD over the Inventor and the SolidWorks. I'm not saying the Inventor can't be used for 2D works. It can be used for 2D works. But I think the AutoCAD basically almost everyone in any engineering field uses the AutoCAD. The mechanical uses the AutoCAD. The construction people, the woodwork people, the electrical people, the civil engineering, the architectures, and other stuff, they all use the AutoCAD for layering. When I say layering, I explained the last time for plotting, right? It's very simple when you use the AutoCAD to even make layering. Assuming you want to install machines in a workshop you want to build. Assuming you want to build a CNC or lathe machine workshop, maybe you can use this to indicate where you want to keep all the machines or install all the machines, you see. So this one can serve, this 2D can serve as a guide. You see, just now I've made a simple layer of plots, like how I explained Friday, that one plot, that's when we have the acre. But this one, we call it layering. That's when maybe I want to install machines, and for my workshop or something, I can just use this, depending on the room size and other stuff. You can just use it, the AutoCAD software, so that you can know how to go about whatever you are doing. So I think the AutoCAD is basically simple and basic when doing 2D drawings, right? So this is the SolidWorks interface. This is the assembly part. This is the so the assembly parts, they said what? A 3D arrangement of parts and or other assemblies. So assembly drawing can be two assembly coming together to form one unit, right? Or two or more parts coming together to form one unit. And the drawing is basically, you see how the drawing typically looks like here. You see a 2D engineering drawing typically of part or assembly. So the drawing part, the drawing aspect just gives you a 2D overview or 2D drawing of just whatever you want to do, you want to draw. So assuming you want to draw, how do you call it? Assuming you want to draw a cube, right? Let me open this part. That's the SolidWorks. With the SolidWorks, it's like the space and other stuff is very huge. So please, when you don't have a high spec laptop, please, I advise you that you stick with the AutoCAD and the Inventor, right? I think with the Inventor, if you have this laptop, TM1, the teacher's laptop, you can run the Inventor software on it. And please, can you all hear me? So that I'll know that I'm not the only person here.
Yeah, we can hear you.
Nice. Okay. Please hold on. All right. So there is the papers, the size. Those of us who don't know, assuming you are doing a project work and you know the project work, the paper size we use in printing our project work is what? The A4, and that's the A4, that's the international. Please, who can tell me the full meaning of the ISO over there? The ISO, the meaning of ISO. Since we are all engineers, you can help us. The meaning of ISO. The meaning of ISO.
That is International Standard Organization.
Yes, it's International Standard Organization, but it is arranged as International Organization for Standardization. That's the ISO. It is arranged as International Organization for Standardization. So that's the ISO. So in even designing, we have standards, right? We have standards we follow. Sometimes in designing, I think last year I was teaching, I think Please, pardon
Two
me.
women down and out of water.
Really? Very interesting. All right. Okay, sorry for that, guys. So that's the.
Please, those who are talking can mute your microphone. The back.
You don't worry. I'll mute them from this side. When I mute them, they unmute and still keep talking. I'll mute them. Please, pardon me. This I'm recording this meeting, so please, any distraction and other stuff will just spoil the video, and this video will serve as a reference. After that, I can give this video to the MEXA president, so that every year when someone comes from level 100, they will start practicing and knowing. You see, they will start practicing from level 100, the basis, right? So I want this video to be of standard. That's why I'm doing this. So please, if you join the meeting, please mute your audio. If I ask a question and you want to respond, make sure the background is not noisy. All right, thank you all. Okay. So as I was saying, International Organization for Standardization, and I was saying that every design, right, has a standard. In engineering, every design has standard. Like the paper we use, even the sheet we use when plotting, you see, they've written A4, that's the ISO, and we all know with the A4, it has a height of 297 and a width of 210 degrees. Millimeters. All right. So when dealing in drawing or mechanical designing, it follows some standard. You can't just draw any bolt and nut. It has to follow a standard. You can't just draw any cube. It has to follow a standard, right? And okay, let me ask this simple question. I was teaching, I think last year, when I was in level 400, I was teaching the level 200s inventor. So I asked the question that, who can tell me, okay, so those of us here, who can tell me the standard angle of a knot? You see, a knot has an angle. The slanted parts, right? The slanted part. I'm not talking about the pentagon or the hexagon, but I'm talking the slanted parts. You know that a knot is not always flat, right? A knot has an angle. A knot has an angle. So please, who can tell me that angle? Who has any clue? I think someone answered in that class. Who has any clue of how the angle is like? Who has any clue? Who has any clue? The standard size for a knot. The standard angle. All right, for learning sake, the standard angle for a knot, right? I think I have to show you. I'll draw a simple knot so that we all know. A standard angle for a knot is what? 45 degrees. Put that in mind, so that when designing, you should know all these things. You shouldn't just design unless maybe how do we call it? Unless maybe you are doing otherwise, or you have been given specifics to do or to follow, right? Unless maybe you have been given a specific some specifics to follow, or some dimensions to follow, so you are restricted. But when you are not restricted, the standard angle of a knot, or a boat head is 45 degrees. That's the standard. And I've not researched into why it is 45 degrees. And even someone can use this as his or her final year project topic. That's the standardization of certain things. Why they make a standard, why it is accepted here. You know, we have standards in United States, we have standard in UK or European countries or the other European countries. When it comes to engineering or when it comes to even measurement, I think the US uses mostly inches, feet and other stuff, but with the UK, they mostly use the millimeters and the centimeters, so on and so forth. So every country or every continent and how they make their standards. But I think it's all do what falls in one basket. They are all the same, since they have engineers there that has channeled that thing since the 80s. So all right, so let us continue. So there is the interface of what the inventor, right? There is the drawing, and this is how the sheet looks like, right? Okay, so when it comes to, let's say, the part drawing, okay, so this was some work I was doing for someone. I was trying to simulate it, but I've not yet reached that stage. I'm now learning how to simulate. So those of us who take this course serious, and I know the serious people. Yeah, I know the serious people. I've seen them. Those of us who take the course serious, I think we'll move on to the advanced level, and I'll deal with you guys alone, so that I know I'm not wasting my time and my energy, because I'm doing all this for free. All right. So those of us who take this serious, we will get to some place. Yeah, we'll get there very soon. Very soon we'll get there. You can call yourself a mechanical designer very soon. All right, so there is the part drawing, and the part drawing, the interface basically looks the same as what the inventor, but as I said, it is a little bit complicated, right? It is a little bit complicated, and I'll not even really find my edge in the SolidWorks, but I think I'm really doing well, and day in, day out. And please keep on practicing. If you stop practicing, that is all. Designing is not something, it's not like mathematics that you have to know only one formula. With designing, the more you practice, the more you explore. The more you practice, the more you explore, the more you get more knowledge on going about something, right? Okay, so there's the interface of the, when you select a part drawing, that means we mostly do one joint drawing. So with a part drawing, you can just select your sketch like this. A window will open. So the moment you select sketch, the plane will come again. The plane I showed you guys in Autodesk Inventor. We have the XY plane, we have the YZ plane, we have the XZ plane. These three planes. Put these planes in mind. So it's basically the same as what the Autodesk Inventor. You see, I just pick my rectangle tool, draw any rectangle, and do what? And dimension it. Right? You can dimension this, smart dimension. Select your smart dimension. Select one side of the rectangle. You input the dimension you do what you want. Right? You input the dimension you want. You get it. You come to this side too. You input the dimension, assuming here is 60 mm or 60 units. I just key in my dimension I want. When I want to change it, when I'm done with my sketch and I want to change this one into a cube, I just do what? I just click this place. Please, can you all see my mouse pointer? This one, not the times. If you times it, meaning you are trying to exit. You just select this one, click done, and you'll be done. Right? You just pan. The pan I taught you using the mouse. You can use the shift method, but with this one, please take note. The shift and the scroll button, that it doesn't work together. You just have to use the scroll button, right? Like this. So I'm done with this one, and I want to do what? I want to extrude or press pull in Inventor. It is called extrude. In AutoCAD, it is called press pull or extrude. In SolidWorks too, it is called what? Extrude, boss or base, right? And this is the base. This term as the base. This is the base. So I just select my extrude. Now you see it has turned into what? My 3D objects, and I just select the height in which I want to extrude. So assuming I want to extrude 50 units, right? This one, the reason why I'm saying units is we didn't really select the standard we want, whether we are using inches, whether you are using millimeters, whether you are using, but I think I've already set my SolidWorks automatically towards this is the unit, so I can change the units. This is what? This feet, inches, millimeters. This is the UIN. I don't know this. This is the millimeter. This is the millimeters. This is the millimeters, right? And basically, this is what we mostly use: the centimeters, the meters, and the millimeters, right? I don't know about the NM and all those stuffs. I don't know, right? And this is the feet, and this is the inches. I think the US mostly use these two. The United States, they are standard, right? So let's say we want 50 units. We just type our 50 units and just press OK. You see, we now have our 3D objects. Very nice one. Very nice 3D object. I can rotate this around just to view it. I can just right click on it to create new sketch, or to create a new sketch and edit the sketch. I can change my dimension, so on and so forth, right? So this is basically how the Inventor works, right? And we have the with the Inventor, right? So let me open an existing design for you to just have it. I hope this one opens for me. I hope it opens. Okay, nice, good. So this was the project I was working on with someone. I'm just trying to, this one, what I'm trying to do is, I'm just trying to test, do a thermal analysis on this. Thermal analysis, when we see the thermal, you all know the word thermal. Thermal simply means heat, right? We all do engineering, so we should know all these things, right? So I was just trying to do a thermal analysis for someone. And this is not my work, please. This is not my work. I downloaded this online and I'm just trying to edit it. So please, those who will be joining my advanced class, I'll guide you through all these stuffs. How to get designs online for free. Some are paid. You can even get contract work and other stuffs online for free. Right? You can get some people contracting you for their designs, their project works, and other stuffs for free. Right? So those who will be joining my advanced class. All right, so I was trying to do a thermal analysis on this, which I'm not yet done. It's still in progress because I'm not really used to the assembly drawing field, and the others. What I'm basically used to and I've mastered it is the AutoCAD, but you're still learning. Yes, you're still learning. So I downloaded this online. This is basically how, when you finish drawing, you see this one. Okay, so today to talk about rendering, how to render your drawing for it to look real, how to render your model for it to look real in real life, right? For it to look exactly how you've planned, adding materials to it, adding colors. So this one, the materials has already been added. You can see the copper windings, right? You can see the copper windings. You can see the fan. This fan is made of plastic. You can see the aluminum chassis, right? You can see the aluminum chassis. You can see the bearings. There are even bearings in them. These are the bearings. These are the bearings, right? These are the bearings which you can rotate. This is the shaft. So you see, this work, you can't do any editing on it because the designer just kept it there for what? Educational purposes. Maybe you want to simulate or do an analysis or something. You just come and you just go online there, choose whatever machine you want to do analysis on. You just come and apply in real time the machine you are going to build. You just come and apply the features. Assuming the machine you are building, the fan is supposed to be plastic. You just come here, you select the material you want to use. Assuming the shaft is going to be wood, you just come here and select the wooden material you want to use, and you make your analysis to suit your real-time projects you are doing right? Okay, so I think we can skip this one. We can hold on to this one for now. Let's get back to the AutoCAD, sorry. All right, so I introduced you guys to the 2D space, and we are still on the how to. So we are moving on to the 3D space, and because we didn't have the meeting yesterday, I think I'll rush a little bit on how to do all this, and what we are going to do much more on how to make your object look real, how to render. It means how to render, right? How to visualize your model, how to make it look real, how to make it look exactly as the machine you're about to do or to build. I was talking to I
Ah,
think Dr. Jima.
what's that?
All right, so I was
I
talking
don't
to
know.
Dr.
I don't know.
Jima. I was talking to Dr. Jima on something, and I think he told me something about engineering in Ghana. And I think he's right. In Ghana, our engineering, we finished doing the real objects. Now we are about to draw. I think it has happened to most of us here. I'm number one. Okay, my project, I didn't do that because I know what I was up to. Right? So I didn't do that. But in engineering Ghana, I think most of the people, most of the projects I handle, right, they finish the real time thing before they bring their work for me to design for them, which is very bad. It's like we are turning the engineering upside down, right? We are turning the engineering upside down. We are supposed to first design the work in the essence that we should have even simulate the work, make an analysis on the work, whether thermal analysis, static analysis, a whole lot of analysis, make analysis of them so that you know that when you go to town, the shafts, the analysis I made, the shafts I used wood, and it helped me very much. You just go to town and just buy wood. You just come and start doing your work. You see, which will help us very more. You see, so I think please, those of us here, let us take it seriously. If you want to design something, even if you don't have the CAD design, make a sketch, make your drawings before you start designing. It is very difficult that way, but I think if you plan very well, you are going to succeed. And if you fail to plan, you are planning to do what? To fail. If you fail to do your designs, if you fail to make your drawings, right, and you start working, picturing whatever design you have in mind, you are going to fail. Eventually, you are going to fail. Right? Eventually, you are going to fail because you are going to find it very difficult. I'm not saying you are going to fail totally, but you are going to find it very difficult to do what? To adjust certain things. Right? So please, let us take note of that. Design your work to suit you. Plan whatever you want to do. Design it. But so if you are done designing it and you start the fabrication process, it's very fast and quick. You not even take 1 week, depending on the type of artifact you are producing, right? You don't even take 1 week. You can do it fast and sharp. Okay, so let us move on without wasting much time. I think we have said a lot, and you have a clue of these three main softwares I use personally. And I told you I use the old versions. I use 2016 AutoCAD. I use Inventor 2020. I use, I think 2020 or 2021 SolidWorks. If you don't have a high spec machine, you can stick to either Inventor or what? AutoCAD. I'm having a high spec laptop. That's why I'm even able to run these softwares simultaneously without any hassle, right? I'm having a very powerful laptop, so I've been able to run this software. So if you want to take designing, mechanical designing, very, very, very serious, please try and upgrade yourself, right? You can start bit by bit. I started from somewhere now. Small, I'm trying to upgrade. And I think it is really worth it. I'm not saying, I'll never say it is a waste of time for me to do what? Upgrading myself. It is really worth it. I quite remember, let me say this funny story. I installed the AutoCAD software for a friend, and the following day, the friend came to me that he wants to install a new Windows. Why? I asked him why, and he was like, his laptop has crashed because of the software I installed for him. His laptop has crashed. So please, if you want to venture into mechanical designing, try and get a high spec laptop. I can give you a minimum spec laptop for it to suit your budget. I can recommend, not give you, I can recommend a minimum spec laptop. Maybe you can just DM me. The spec that will help you. I can help you out with it. And after this meeting, I'll also show you the specs of my laptop so that if anyone wants to purchase it, the person can go ahead and purchase it. It will really help you. It has really helped me. I can open SolidWorks, Inventor, AutoCAD, Photoshop. I can open a whole lot of designing softwares simultaneously without any hassle, without any lagging, without slowing down and other stuff. All right, so let us continue. Please, any question up to this point? Any question? Any question? Any question? Any genuine question?
Let's move on because of the rain.
Okay, please. You wanted to ask a question, right? Or the person who just said let's move on. You wanted to ask a question. Ahine, please, do you want to ask a question? If you think the network at your end is not that strong, I think you can type your question, right? I'll see it here and answer it for you. At the chat section, you can type your question. Yeah, you can type your question and I'll answer it for you. And also, please, we will have a guest today. I think I said it in the group. We will have a guest today, and it's a plus or bonus for everyone who wants to be financially stable. I think we'll clear all doubts on forex trading too. At the end, we'll use the last 10 minutes to do that. It will just be a brief introduction. I have a forex guru who has really made it out of these financial markets. A whole lot of stuff, this cryptocurrency thing and a lot of stuff. So we'll have a legit person joining us. He's not a small boy like that. He's not a small. He actually owns a company, a waste management company, a huge company, and other stuff. So please, let us join or let us keep being active online like this. All right. So without wasting my time, let us first talk about solid 3D solid objects or 3D solid drawing. So let us just create a sketch, right? Let us just draw a knot so that I'll show you how to render or make it look accurate in real time, which is going to take time. So please, I think with that one, it takes time, right? If you want to render something, you get to appreciate it. If you want to render something, rendering only one solid object can take 30 minutes. You can just be there 30 minutes without doing anything, just watching the thing finish doing his work, right? So please let us bear with me. But with my laptop, I think we can use 8 minutes, 10 minutes to just render one artifact. Let me put it that way. So without wasting my time, I'll draw a knot, right? I'll give the step-by-step process I used in drawing the knot. All right. So a knot has a whole knot. Let me put it that way. Okay, a knot is whole. Guys, it is about to rain, as my friend. I am just praying the network don't mess me up, and the noise also don't mess me up.
Don't worry. It's gonna rain. Don't worry.
It's about to rain. I'm just praying the network won't mess me up and the noise won't mess me up.
Don't worry. Don't mess up. We have put everything already to mess up.
All right. Okay, so
Yeah, it's raining. We had this every day.
all right, so let us continue. So a knot has so many features. A knot has angles. A knot has circles. It has what? Polygons. It has what? Threads. A boat has threads. A knot has internal threads. A boat has external threads, right? So today we will just, because of time, right, we'll just draw the boat and the knot and we do what? We render, right? We render. And I pray that today we are going to close around 9, yeah, because we will do a whole lot of things and it will be hands-on, no book, or no opinionated PDF. What I'm saying now, everything is from my mind, right? Everything, the dimensions and everything, I've not planned for it, and we'll adjust ourselves to it since we are all engineers. So I'll first check my working space. Whenever you're about to work, right? It's like you're about to eat. You first do what? Wash your plate. So I'll first make sure everything is okay. The dimensioning, the units, right? The unit is to what or meets the requirement I need, right? So what I mostly do when I want to check all these things is what? I'll just pick any line. I'll just pick my line 2 at the draw tab over here. I'll just draw the line. Now you realize the units over here, the numbers highlighted in blue, right? The numbers, it is very huge, right? And I want to deal with something like 20, 5, 10, and so on and so forth. So what do? I'll just zoom in into my grid, right? I'll just zoom in into my grid, right? So I'll first draw this line like this, and I'll start doing what? Zooming in. And I'll make sure to get this in. Make sure that your coordinate is always there. We have a way of removing this coordinate, but me, I prefer the coordinates will be there so that you see whether your work, sometimes when you're drawing, you see your work turning upside down, blah, 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 and so on and so forth. So what I'll do now is I'll just try and zoom in. When I zoom in one, using the scroll button, when I zoom in one, I'll just shift the coordinates here, because when I zoom in again, the coordinates will be moving, right? I don't want to get, or I just want to spot the coordinates, right? So now I've zoomed in. I'll take my line 2 again and check. So now I think it is coming to the dimension I need. Now I think it is 73.5, whatever, right? So with that one, I think I can work much on it. I can work on that one. It is very easy for me to work. So what I'll do again is I'll just zoom in again, a bit small one like this. Now my working space or working environment is what? It's very neat. Okay, so with the rendering we're about to do, we'll do one in AutoCAD, both and not. One in AutoCAD, both and not. Oh no, we can do the not in, because with the inventor, when we say we are about to do the both and not, unless we use the assembly method. Rate that one, I don't want to dive into it very much because I will reserve that one for the advanced people. Okay, so we will do the not at the inventor side and we will render it, make it look like a real object, and we will do the both and not at the AutoCAD side. So those who will not be joining the advanced class, please focus on the AutoCAD class, AutoCAD class, AutoCAD side, and you can apply the same method or the same process using the inventor. All right. So let us continue. So now I have a clean working space. I'll make sure, and last week I also said something over here with a snap objects. Make sure these things are what? Turned on. The end points, the midpoints, the center, the geometric center, the node, the quadrant, the intersection, the extension, so on and so forth. Make sure they are turned what? On. It really helps. It really helps. Okay. So now I'm about to draw my knot. Please follow my way. If you go online, they have another way. If you go to YouTube, they have a lot of ways to draw a knot. But I think my way is very simple. I've tried and figured out how to do it very simple and easy without any hassle. So without wasting my time, I'll pick my tool. And as I was saying, the things you need to draw a knot, you need a circle, you need a polygon, you need what? A thread, whether internal or external, right? So what I'll do now is I'll pick my circle, right? I'll either pick my circle or pick my polygon first, right? So for educational purposes or education's sake, I think I'll use the circle first, and I picked what? The first one, that's the center radius. It means from my center to the another end point, not end to end. Center to the another point. I'll just pick this one. I'll just draw a dimension to suit what I want. So I want to use a knot size of what? 20 mm or 20 units. Since we didn't state any units, I'll just select 20 units. So I'll just type in my 20 on my keyboard and press enter. Now I have this. Please, when you are done with any command, you see the moment I pressed enter, there were a lot of stuff over here. Make sure you press escape on your keyboard, and this will do what? Exit all existing commands for another, or pave way for another command to do what? To be activated or initiated, right? Make sure always, the moment you make a mistake, make sure escape is your first thing. You press escape, else one day you might miss out. You might make a mistake. I've made that mistake before. I did a 3 hours drawing and I made one mistake, and I'm supposed to do everything over again. It wasn't easy for me that day. It wasn't easy at all. All right, so let us continue. I've picked my circle. Now what I'll do is I'll pick my polygon. I've selected my polygon, and now they will ask you the number of sides. You see, we have knots that has only 4 sides, but we are using the standard one, the standard knot we all know, that has what? 6 sides. So you just type in 6 on the keyboard, press enter. And now because we have our snap objects on, the moment you drag it to this circle, it will give you the center. You just locate the center and you just will do what? Left click. The moment you left click, it will ask you whether you want to use inscribed in circle or circumscribed about circle. This is simple. I think this one was taught level 100. Inscribe and circumscribe. Inscribe means what? Being in something. Circumscribe means being around something. Now, how do you want our knot to be? We want it inside, right? We want it inside the circle. So what do we select? We select the what? Inscribe. Now the moment we select inscribe, this is what it does. What it gives us. This is what the inscribe gives us. And when we select the circumscribe, this is what the circumscribe gives us, right? So with the circumscribe, the polygon or the hexagon, please, is it a 6-sided figure is what? Please, let us make this meeting a discussion. 6-sided figure is what? Is it?
Hexagon.
Yeah, hexagon. Hexagon, good. So we are using, when the moment you pick your hexagon and you select circumscribe, the hexagon do what? Comes outside the circle. You see, because of the tools I selected over here, it has locked it for me. Dimension, for precision's sake, it has locked it, right? But when I pick circumscribe, because I want it inside the circle, I'll do what? Pick the circumscribe method. Hey. Right, please, I'm coming in. I think. All right. I think I've mistakenly pressed something. So, all right. So let us do it again. 20. Let me see something. Okay. Select our hexagon. Select our 6 side. Why is this not coming? Why is it not coming? Why is it not coming? Okay. Well, the reason why it's not coming is you have to press enter. The moment you select the 6, you have to press enter and you have to specify the specific center. You want it inscribed. You select this midpoint. Simple as this. It's as simple as ABCD. Simple as ABCD. Simple as ABCD. Now, we want the hole or the thread in the knot to be what? Let us pick our circle. So we will pick our circle. We are about to create that hole. So we will pick our circle like this. Locate the center point. Drag it now. Let us see the one that suits it. I think 10 will do, right? 10 units. So we just type our 10 units and press enter. Now we have this nice what? thing, nice looking thing like this, right? So we are about to convert this 2D object, this in 2D form. We are about to convert it into what? 3D form. And it is very simple. It is very simple. What we are going to do now is we will just click this home button over here. This home button over here. You just click it like this. Your drawing has been changed to 3D, right? You just click this home button over here. It has been changed to 3D. Now you are done, and that will be all. That is all. That is all. Please, any question up to this point?
Yeah,
please
we
go
did not
back again.
Hello, please, one after the other. One after the other.
Yeah.
All right. Okay.
did not see the button that you click.
You said?
I said I not see the home button that you click that give you the
Okay.
3D,
It is this one. Can you see it? It's like a house. It's like a house over here. Where my
okay, I
mouse
see
pointer
it
is now. Yes. Or you can equally click this one. This side. When it comes to the navigation, we are now using the west south or southwest. This is it. The southwest is the same as using the home button, right?
Okay, thank you. I've seen it.
Okay. Any question? Any more question? Any more question? Please, do you understand everything up to this point? Do you understand it up to this point? Can I move on?
Yeah, we understand.
All right, I think
Yeah,
someone
you can
has
move
a
on.
question. Let me check. Please, using the AutoCAD and the Autodesk, does both follow the same procedure? Okay, I think someone has asked a brilliant question. Okay, so I think someone has asked a brilliant question. Please, the person said, please, using the AutoCAD and the Autodesk Inventor, does both follow the same procedure? Basically, it follows the same principle. The principle is almost the same, but some of the commands is slightly different. The AutoCAD and the Autodesk, the principle is the same, but the command is what? Slightly different. Okay, so the person who asked, Zoom user, you asked this question, is basically the same, but the command is what? Slightly different. So please take note. We will go there. We will also go and render at the Inventor part 2, and you appreciate, you know the difference when drawing not using AutoCAD, you know the difference when drawing not using Inventor. If time will permit, I also do that on the SolidWorks as well. All right, so we can continue. Now, the next step for us to do is make this work look like a 3D. And what tool do we use? I selected some tool at the SolidWorks side. You use either the press pull or what? Extrude. But with AutoCAD Inventor, with the trick I know or the method I know, we'll use both the extrude. This is the extrude from the modeling section. This is the extrude. We'll use both the extrude and what? The press pull. Now the meaning of extrude, it creates 3D solid or surface. Creates a 3D solid or surface by extruding a 2D or what? 3D curve. When extruded, open curves create surface, and what? Closed curves create solid or what? Or surfaces, depending on the specific mode. For surfaces, use the what? Surface modeling mode. So this mostly intense, like it's like I'm really diving into it. So you just let us just stick to what we are doing. But the extrude has given us a clue that it creates what? A 3D what? Surface. We want a surface. First, creating a knot, we want a solid object and we want a surface in order for us to create what? The angle. Simple. Good. So what we'll do is I'll select my press pool to highlight this area. The moment I bring my mouse pointer in like this, I select it and I'll move my mouse up like this. I want it to be what? Let's say 20. I want the height to be 20. Like this, 20. I know now it is becoming plenty, but I will change it. For me to change it, I would select this visual style. I talked about it on Friday, and I'll select, I use shaded of gray. You can use conceptual, you can use shaded of gray, right? So this is your knot. Basically, this is your knot. Do you all agree with me?
I agree.
Yeah. I agree.
So basically, this is your knot. But there is something missing. Who can tell me the thing missing? What is missing? What is missing?
Yeah, the thread inside.
No, you apart from the thread, we will not do the thread because of time. I will reserve that for my advanced students. Yeah, I'll reserve that for my advanced student. But I'll do the thread on the boot. Don't worry. Someone was saying something.
The sides are not the sides.
The size,
angle.
the angle, yes.
Yeah,
The
the
angle.
angle.
You see, looking at a knot, right? Let me see whether I can quickly. All right. So let us use this. Very simple. All right. So can you all see my screen?
Yeah, we can see it.
Looking at the knot, you see, there are these curves over there. This curves over here. Right?
Yeah.
Okay. I think someone will challenge me. This is a drawing. But someone will challenge me. This is a drawing. This is not a real knot. This is a drawing. This is a drawing. I know what I'm saying. This is a drawing. This is not a drawing.
And how do you come by the shadow?
The shadows. Yes, we will get to it. We will get to it. See, I'll do all. Right. That's when the rendering comes in place. So now this one you see here, it has been rendered to look what? Real. Do you get what I'm saying? So now, without even someone an expert telling you that there's a drawing, you wouldn't know that there's a drawing. There's a drawing. They used either SolidWorks or Inventor or Blender or the other stuffs. This is basically a drawing. There's a drawing. This one is a drawing. There's a drawing. So now let us focus and continue. Now we have what? These curves, this one. That's what they are going to do now. So let us get back to our work. Now we use the first tool we used to turn the hexagon to 3D is what? What tool did we use? Brainstorm. What tool did we use?
I think we use the extrude or
with this one we use the press pool, because this one becomes what? Okay, let us read the meaning of the press pool, right? I think that one we will really appreciate it. Okay, get visual feedback as you move the cursor after seeing a 2D object or an area formed by a cross boundary. Well, basically, this one becomes our boundary. That's why we use the press pool. Our boundary. So we can't cross this boundary, right? But with the extrude, it is going to create what? A surface. Grasping the knot, right? So let us select the extrude. You appreciate it more. So I'll advise that when doing this, right? When doing this 3D, dealing with 3D, you just use this menu, solid, up there. You just click solid. Everything you need about anything solid is here. When you want to use surface, everything you need about the surface is here. But with this note, the reason why I'm sticking to this menu is that one is solid and one is what? Surface. Press pull is solid and the extrude is what? Surface. We have solid extrude. We have solid extrude, right? Solid or surface by extruding. Solid extrude. Good. So we will select our extrude tool like this. Click on the circle, right? You will come and find the circle. Click on the circle like this. Press enter on the keyboard. Now, what height from this side to this height? What was the height we used? We used some particular height. What was the height? Let me see whether you guys are focusing. The height we used. Yes, who can remind us of the height we used? Yes. Hey, 20.
Yeah.
Yes, we use 20. And because of all right, so we use 20, but because of some of the features we've turned on, you can just locate this point. You bring your mouse pointer to this point. That's the end point of the extruded hexagon, and just click it. It will just give you the height. Now you see the drawing has changed to something small, right? Now the hole is missing, the polygon 2 is missing. We can only see the shape in it. Now what do? We want this thing. This is what we want, right? This is what we want to achieve. I'm just trying to see whether I can. Oh. Good. So this thing, this is what we want. This thing. Pa. You see, it is an angle, but it is not just a straight angle. It's what? A curved angle. Am I right? Am I right?
Yeah.
Yes,
Yeah.
it's a curved angle. It is not just a straight angle. We have a straight angle. Let me give you a scenario of a straight angle. Have you seen the milling machine we use at the workshop? If you have used it before, the tool we use, right? The removable handle we use. I think that's cutted not over there at the mouth of the removable angle. It has a straight cut. That formula is different, and this formula is also what? Different. Okay, that formula is different, and this formula is also what? Different. So this one, the formula we will use, because it has a curved angle, what tool do we need? I think I talked about this too. The first day we did this meeting. Let me draw a small box over here. I talked about these two, filleting tool, right? Where you select this side, you select your fillet tool over here. Select the radius you want to fillet. As I want to fillet 5, select my 5. You see it has been curved, right? You see the corners has been curved with a filleting tool. The corners has been curved with a filleting tool. These two, right? Okay. All right, good time with you, Sir Abraham. Good time with you. All right, so nice having you with us. So he's our senior, right? He's our senior, and he just sent me a message that he's very sorry for the inconvenience. He's one of the serious people I know when it comes to engineering. He's one of the serious people I know. So please, all right, thank you for having me, or thank you for joining my class. It's a privilege teaching you. All right, Abraham sir, it is a privilege teaching you. Thank you very much for your time and efforts. All right, so please, all right, so let us continue. So please, after here, every recording we do, right, will be pasted, because the recording, the file is too large, 200 megabytes, 300 megabytes, 100 megabytes. So I can't send the recording or put the recording on WhatsApp. So the recording will be sent on Telegram, right? After the meeting, I'll forward a Telegram link to you. If you want to download the video, I'll keep all the videos over there. Okay. All right. So thank you for having you, sir. So we can continue. All right. So you see this fillet to give us a curve shape, right? The fillet over there give us a curve shape. Very nice one. So with this one, we are going to use, this one is what? 2D, right? Please unmute and talk to me. Please unmute and talk to me. Hello, can you all hear me?
Hello.
Hello, yeah, can you all hear me?
Yeah, I can hear you.
All right, so I said the fillet we used, this is a 2D fillet, right? This is a 2D fillet. And the tool we are dealing in, the knot we are about to do, it is what? A 3D knot. So what are we going to do? We are going to use, or it is a 3D or solid knot. So what are you going to use? We are going to use a solid fillet. Now with that one, you come to what? Solid. We have fillet. You see, this is the fillet edge. That's a solid. So this rounds and fillets the edge of what? Solid object. Do you get what I'm saying? So this fillet rounds and fillets the edge of what? Object, simply object. That's 2D. And this solid fillet rounds and fillets edge of solid what? Object. Simple. So we will select this solid object filleting. We select our tool like this. Now what do we do next? We select our radius. Where can you find the radius? The radius is found at the command section. I talked about this during the first section. This is the radius. Now we are using 20 because the height is 20. We will select a suitable radius for us to do what? To use. So I think for us to get a nice curve, let us try using 5, radius of 5 units, right? So I'll type in my 5 at the space provided here, press enter on my keyboard. Now I can apply the command. Now I'll select the first edge of the circle and select the corner, both corners, and select this one too. Now what do? I'm done. I'll press enter on my keyboard like this. Enter. Please, have you all seen it? Should I go over?
Yeah, please go over.
Okay, it is really getting interesting. All right. So I said I'll do what? Select my fillet edge. This edge like this. Come and select my radius. I want to use 5 units. I'll select type my 5. Press enter. Drag your mouse pointer to. You see this top, right? This round curve. Okay, let me put it this way. The circle we extruded, that's what we are going to select. Right? We use press pull for this side and we use extrude for this side. Right? So we will select the edge of the circle like this. Click on it. Drag it down to, you will not click and hold, just click on it. It will just select it. Move your mouse pointer to the downside to click on it and press what? Enter. On the keyboard, you get something beautiful like this. So you press enter twice on your keyboard, you get something beautiful like this, right? Now it is getting interesting. I think we have only one more thing left for us to do what? To do. We have only one more thing left for us to do. And that is to cut out this part for us to get the smooth edge. And the tool we use for that is what? Intersection. Now, when we say intersection, basically in the layman's language, what is the meaning of intersection? Intersection. Who can tell me the meaning of intersection?
The point that two lines join. Like two lines.
Simple. A point at which two or more things intersect, especially junctions, or a point or line common to lines or surfaces that intersect. You see, intersects planes. Some of the planes do what? Intersect. So we want to what? Intersect this side, this part. It's meeting what? This part. Right? So we will intersect this part and what? This part. Just to make them what? One. Do you get what I'm saying? Simple. The tool we need to use is called what? The intersections tool. And this tool can be found at the solid. This is a solid. You can use this intersection, the solid editing, but I prefer this solid editing. You see the boolean, or the boolean. You see union, subtract, and what? Intersect. So I'll select this intersect, what? To select this one, right? And select this one too. Now I'll press enter. Now you have your notes. Nice one like this. Very simple and easy. Should I go back?
Yes, go back.
Hey. Go back, Papa.
Amen.
They say, you don't want to miss one thing. All right, so let me go back. All right.
You are moving fast. You are moving fast.
It is because of time. I'm sorry. It's because of time. It's because of time. I'm sorry. I'm really, really sorry. Because of time. Because we need to do a lot today. We need to cover a lot. I need to teach you how to render. So we will draw this thing too at the inventor side too. In the inventor the other day, make sure from a book because I've been lazy these days processing the inventor because I'm used to the ToCAD. But don't worry, we will see through. All right, so with this one, I said we will select the intersection. This one, you see, when I select this one, it is different, right? You see, a small portion has been highlighted what? Blue, right? Am I right? And when I select this one too, it is what? Different. This one. That one too is different. A different portion has been highlighted what? Blue. And I want to do these two solid sections to intersect, right? So I'll select this intersect to at the boolean where the solid menu is. I'll select this intersect to. Select this part, right? The circle part, and select the hexagon. Select that one too and press enter on my keyboard like this. Simple. As simple as ABCD. I hope it is clear now. It's clear now. Good. Nice. So now I'm done with everything. So I'll press escape till I see command cancel. So that I'll know that I'm about to deal with a new stuff altogether. Because sometimes when you load up the commands, so many commands, you do what? You mess it out. You mess the whole thing out, right? Okay, so now we have our knots nicely drawn like this. Without wasting my time, please let me see whether I can do the threads in it, right? I'm not trying to confuse anyone over here, right? But please bear with me. I don't want to, that one is for advanced class. So I'll not ask whether you understand that part or you don't understand that part. It is just a bonus, right? So let me rush and do. So please be observant. I'm about to cut the threads in it. I'm hoping this works out because I don't want to do it. All right. So I'll move this knot somewhere. I'll just click on it. This plane will come whether I want to move to the X, the Y direction, that's up, the Z direction, or the X direction, or I'll just use this. Okay, sorry. I'll just use this home tab, select my move tool, select this object, select the point at which I want to move this work, or I'll just drag this one somewhere. Click on this and drag it somewhere like this, so that I can use this one very well. I can make use of it because this is the same thing we are going to use to create what? The boat, right? This same, because we don't want to go back with the dimension and other stuff. So that's what we are going to use. So let me try and cut the knot, the threads in it. Let me see whether it will work out very fast for me. All right. So it was 20, right? I'll just select my 20. Okay, let me see. I can select it, move it to a different direction. Hey, beautiful, you are doing. I'm showing you all my tricks. And with the best menu, so don't worry. I'll select my sweep at the modeling. There's the helix. I talked about the helix. So if you really understand what we did yesterday, you really appreciate what I'm doing. I'll select my move to blah 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 blah. Oh God. Okay. All right. So you see, I've made one mistake. I'll select my sweep. Select my move to, select this one, locate the center of this, bring that one here, bring that one here like this. Now, I think the heights, so I was supposed to change it at the top. The heights can be changed at the bottom, but I refuse to do that because of time. So I'll just subtract, use subtract, this main thing, press enter, subtract this, press this. Now I have my thread cutted in it nicely like this. Right, I have my thread in it. It is not perfect because I didn't use any dimension. I hope you can all see it. Can you all see it?
Yeah, we can see it. We can see
Do you want me
it.
to go back?
A little bit.
No. For this one,
Yeah,
I can't
you
go back. For this one, I can't go back. So let us move forward. So let us assume I've drawn my boat and my knots. All right. So we're about to do the boat.
If you go, you will appreciate.
Yeah. You really appreciate it later. Mom, you're bad too much. All right. Mom, you guys don't want me to get money. You don't want me to get money. You don't want me to get money. You want me to lose all my investments. But it is not bad. It is all good. All right, so let us focus on the knots right now. The boat. So the boat, I'll select. We'll use this same procedure. I'll just select my circle like this, locate the center, drag my circle. The pointer should be at this point. Press it like this. Now, okay, we can still maintain this this one, which will serve as our knot, the boot. You see the boot, the long thing, to serve as the boot. And I'll just pick my press pull this. We did this one, I think we used 20, right? we will extrude this one. So it's just, I'm repeating the same method we use for this thing, the knot. I'll just come to my solid, select my fillet. But this one, you know, only one side, when you see a boot, only one side is what has the angle. Only one side has the angle. You see, the downside is flat, right? Can you see from my screen? Can you see from my screen?
Yeah, we can see it.
Yes,
The
we can
downside.
see.
Yeah, only that. So the downside is what? Is flat. The downside is flat, and it's only the top side that has what? The curve, right? There is an Allen knot which can be drawn easily. So you can you tell me this? If this is real, this is a real something. Really? Can't you see something that has been drawn? Can you tell me, guys? Can you tell me this is real?
No, this is not real.
This is not
Not
real.
real.
This has been drawn. This is a drawing. You can see
No,
it.
this. Yeah, it has.
Drawn because you
Yeah,
can see
I
the-
drawn it.
Hey, wow! Then you are a boss. Then I think you even have to take over the class. All right, so let us continue. So with that one, we are only going to curve one side, and we are only going to curve this side, right? The downside, because we don't need it. So I'll select my fillet, select my radius. I'll maintain the 5. Press enter, select this side, press enter 2 times on my keyboard. Now I have this. You get something like this with only one, doing it for only one side. Now I'll select my intersect like this. Select this one and select this one and press it. You intersect now. You have your knots like this, your boots like this. Now what do I do? Now I'm done. I'm almost done. So what do? I need that long thing. The boots. I need a real boot. So I'll just select my press pull, select this area and stretch it out. Right. So let me make it, let's see, 100. Let us use 100. Now I'm done. Let me teach you another thing too. It's a new thing. Do you realize this and this? They are both different. They are not one unit. When they are not merged together. This and this, they are not merged together. So what do? I can use this tool at the solid editing. We call something solid or union, right? And it gives us the meaning of what? Combines selected 3D solid or 2D region by what? Addition. So you can combine 2 or more 3D solid surfaces or 2D regions into a single composite 3D solid surface or region. Into a single, right, composite 3D solid surface or region. All right, so you select this one. You select this one. You can highlight. You can just highlight on your mouse like this, or you can select this one, select this, and press enter. Now we have one. You have it as a 1 unit or solid unit. So I'll move this one to at a different side. Now, what is left for me to draw? What is missing? What is missing? Can someone tell me the missing thing? What is missing?
The thread.
The thread. The thread, the 2 I talked about, what is it? If you're able to answer, I'll move slowly on this one so that you understand. If you're not able to understand, answer it, come to the advanced class, I'll teach you. What 2 did I select? One person can save you all. What 2 did I select? The 2 I selected. I talked about something. The other, I think Friday. If you join the Friday class, you should be able to answer this one easily. Easy. 1, counting up to 5. 5, 4, 3, 2, 1. Okay. So I selected what? Helix. This is the helix. Right? Helix. The 2 I selected was helix. So I'll select the helix. I'll come to where I want to draw the thread like this. I'll just draw it, and this whole diameter, it is 10. I know it, but because I'm using snap object, it is helping me to identify or locate the diameter. You see, automatically it's 10. Now what do? I'll click on it twice again, click the second one. Now I have the trace on it. Now these are the things I was talking about. By default, you have to select the heights. By default, the turns are only 3 turns, right? So I can select turns, right? You see, it is only 3 over there. So let me make it a little bit nice and beautiful. So let me select, let's say 30 turns, and let's see how it becomes. Nice. So now these are the turns, right? I can select this part, right? Nice. So these are the ways, or what I'm about to do is I'm about to draw, how do you call it? The thread. Now I'll pick, you see, how many type of thread do you know? The threads we have. The common ones. The threads. The example of
Rough and
threads.
smooth. That red.
We have the coarse
Rough and
thread,
smooth
and
thread.
yeah, that's the coarse, and we have the.
Actually red. But
So what I'm basically talking about is, you see, we have square threads, we have triangular threads. Have you heard of square thread?
yes.
Yes, we
Yes,
have
we have
square
that.
threads. We have square threads, we have rectangular threads, right? And with that one, if you change it like this, you will see it as square, like the cuts will be in the form of a square. So what I'm about to do, I'm just about to use a circle. I'm not about to use the triangular trace, or the triangular trace. I can do it. I can just pick my tool, draw a simple what? Triangle like this. I'll draw a simple triangle like this and make what? Trace out of it. But that's not what I want. Let us just use the circle method. I'll just draw a small circle like this. Let me use okay, 0.9 is cool. 0.9 is cool. Like this. I just come to the modeling part, select my sweep, select the small circle I drew, press enter, and now select this one like this. You see, this when you are using a normal laptop, you find yourself wanting, because it needs processing, right? You see, some people might cut the trace and leave it like that, but I prefer it to be cut internally. So I'll select my subtraction method, select the main subject, press enter. Now select the trace and press what? Enter. Now I have my circle threads. You see, it's showing like a circle. You see the cuts, the grooves. You see the grooves. You see the grooves. Showing like a circle. Very, very nice. Very, very, very nice. But there's one thing we did, one mistake we did. Please come to the advanced class. We didn't chamfer. You see, you can't just use any knot like this. You have to chamfer. Chamfer the tip for easy penetration. For easy penetration through the knot. Alright, so we have the knot like this. I'm about to rotating. I'll use the gizmo. There's a 3D rotate. I'll just click it. Click my red something. I want it to be nice. Okay, so let me first fix my knot in it. So I'll select my knot, move command, select my knot, select the center of my knot like this. Place it here. Place it here. Now I can drag it down. I can drag it down like this. Very, very, very nice. Like this. Let me delete the unwanted drawings. Now you are done with your both and you're not. Now, I want this to look nice. Now, we are about to enter another section of this class. That's where I'll talk about the rendering, how to make it look real, right? So without wasting my time, I'll just rotate this not for it to stand so that we can have so let me give it some 45 degrees, so you can type the angle you want it to stand. So let me give it some okay, 2. Okay, this angle is okay because it's very nice when it stands like this. See, now we have every detail. It is not really detailed though, but for explanation purposes. Please, does this really look like a boot and a nut?
Yes.
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 So we can proceed. So with the rendering environment, we have solid surface mesh rules. So let's visualize, because we are about to make the thing look what? Real. Do you get what I'm saying? We are about to make it look what? Real. So I'll select my visualize. A whole lot of different kind of menu will do what? Will pop up. Because I'm using a high spec laptop, I would like to increase all the, you see, when you are rendering, when you are in a rendering environment, let me introduce you to the rendering environment first. With the rendering environment, you have the visual style. Now, this is where you change the visual style to what? Realistic. When you select here, you see realistic. Now, this is how the nut looks like realistically without applying any material, right? Without applying any material,
Okay.
this is how the nut really looks like. I'm coming, please. Okay, so let me. I think someone just joined. 2 people just joined the Zoom, the channel. Let me update the channel. So why did a lot of people join the thing like that without joining the class? Really? So on the, it is called following the crowd. Or what do you guys think? Following the crowd,
But that's it.
yeah,
Following the crowd. Some they just
yeah, they just feel they are doing the course, so they have to be there.
You see it.
I knew this how it will the turn out to be. I knew it, so oh, for sure.
Me,
I
I
knew
was even afraid of the numbers, whether all of us can be part of the distance. But
Oh,
when
yeah,
we
yeah.
came inside, we were not.
Oh, I can host 100 people. I can host.
That's
100
what
people.
I saw the other.
Yeah. So I was
And we are also
also scared. Yeah, there were 100 and something. So I can host 100 people, and I knew definitely I've joined classes like this before. When you are late and the class is full, when someone network messes up slightly, you get a chance to enter, and the person will be out. Yeah. Okay, so let us continue. So this is the environment. Now with the visual style, we change it to what? Realistic. We want the object to look what? Realistic. Now we can choose to add shadows. So the person who was asking where from these reflections and shadows, it is here, okay? The reflections and the shadows is here. You can add ground shadows. You see the shadow. You can add full shadow. I prefer no shadow. Sometimes I prefer shadows, sometimes I prefer no shadows, because the designs I do for people. It is not a beauty contest or designing competition. It is their project work. All right. So, so the next important thing we are about to discuss is what? Material selection. Material selection. Material selection. Right? Material selection. Material selection. Very, very important. Very, very, very important. To become a designer, it's not only about drawing, it's about material selection. So before we continue, any question? Any question?
Yeah, I have a question.
Okay. All right, please, I'm listening to your question. And please, the person talking at the back, can you mute yourself? Please.
Yeah. So
Please start
you are turning the boat and not to a realistic, but as for me, I haven't seen that thing like that. I only see the shadows, but for the realistic, I haven't seen it yet. That's why I'm
okay,
asking.
I turn it into realistic, right? This is the realistic I selected. We are not yet, we've not started the rendering. You render it before it looks realistic.
Okay.
Now, we've not added any material to it. Whether the bottleneck was made out of wood, we don't know.
Okay.
So we are yet to add the materials to it, right? For it to look what? Realistic.
Okay, thank you.
To add the materials to it. Okay, so let us add the materials. So now, when it comes to what? Hey, how did this thing just come? Okay. So now when it comes to the material selection, it is very key in all designing you do. When you are designing for someone, you ask the person because you want the thing to look exactly as what the person is about to fabricate. Whether the person is going to use wood, whether the person is going to use concrete, whether the person is going to use metal. If it is metal, what type of metal? If it is wood, what type of wood? Is it maple wood? Is it checkers? Is it, when it is metal, is it stainless steel? Is it steel? Is it a brushed steel? Is it aluminium? Is it gold? Is it a polished aluminium? Is it how do you call it? Is it a cast? Right? Is it a bright cast? Is it a bright polished cast? So on and so forth. Right? So when it comes to the material selection, it is very key. Sometimes when I'm there and I'm not doing anything, that's what I do. I just pick and I just draw anything, right? Just draw anything, I just draw anything. Mostly I just use the boat and not because it is very easy to draw. So I just draw anything and just be applying the materials. I'll render, apply materials, render. Just to see the materials that suit the thing in what? Realistic view. Do you get what I'm saying? So it's very simple. I come to the material browser. This is the material tab. So I select the material browser. A browser will open for me. So I'll expand this one. So let me expand it a bit. Let me expand it like this. Let me expand it like this, right? So these are the materials we are going to use, right? Good. So these are all the materials. We have ceramics, we have concrete, we have fabrics. When you want to do what? Finishes, we have it. When you are doing flooring design, when you want glass, liquid, metals, metallic paints, mirror, paint, roofing, slide, site work, stone, wood, all these design, but we mostly deals in what? The metals, right? So these are metallic paint. These are the mirrors we can use. These are the paints. These are the roof, especially when you're designing roofing. Maybe when you're designing a building and you want to use roofing, these are some of these things. But we mostly use metals because the metals has what? The aluminium. All this has the way it appears, the way it looks. You can edit it to suit your liking, right? We have this. I mostly use this anodized blue, anodized black. We have the anodized red, gray. We have the bronze, right? We have the chrome. You see chrome color, it looks very what? Shiny, like silver. We have chrome. We have copper. We have a whole lot of design. We have gunpowder colors. We have gold, right? We have polished, right? We have stainless steel. We have stainless polished. We have stainless polished bright, and sometimes I prefer these designs, right? This, all right. Please mute yourself. All right, good. So we have stainless steel, brushed, we have galvanized, we have titanium, we have weld. If maybe there's a portion you did welding, you can apply it to that small portion only when you do it, right? We have zinc. So we have a whole lot of what material. We have steel cast. It will look exactly like steel cast. We are all right. So when I'm drawing both a knot, right, the design, the material I mostly use, because I've tested most of the designs and I've realized this type of material, where is it? It is a polished bright something. There's a polished brushed stainless steel bright. I don't think it's this. So to apply the material, you select the material you are applying it to, and you select what? You select this small arrow, add material to document. You just add it like this. Now the material will be added. You see now the thing has changed. The color has changed, right? You see now the color has changed. Please unmute and talk to me.
Hey, the color change. Wow, nice. It's nice. Yeah. You look realistic.
Yeah, so we are about to make it look realistic. Real realistic. Okay, so without wasting my time, let us go. So now, I think if only we are... Okay, someone wants to talk about the network. Okay, so please, when your network is good, you come back again, or you can type if your network is very bad. All right. So let us continue. So we have the polished and we have the semi-polished too. We have types too. You see, these are what the category. These are the types and these are the names. We have metal. Maybe if you want steel, these are steel. If you want what? Fabricated metal, fabricated. These are the fabricated. You see, so many types. So let us stick to this one. So now we are done with the selection of what material, so we can exit this one. So this up here too are the materials we've applied on the artifact. So we can skip this part. Now we have the boots and nuts on the screen, very nicely drawn. Now we are about to enter the rendering environment, right? We will rush it with the inventor, right? I'll let you have a look of how the inventor looks like. When you are doing it at the inventor, it looks like. So we'll just come here, render. You just select render environment and what? Exposure. So we will turn the render environment what? On. Now the render environment is on, like this. Now we can use custom colors, right? We can use custom colors for our render environment. So maybe let us use a plain background. So I'll select use plain background. We can use gradient. You don't want to use gradient. You can use image too as the background, but you want to use a solid color. Sometimes I prefer this color very much. I think it's very nice. This color. It's not white, but it's very nice when designing with this color. And this one, you see, the material is too dark, right? So I want to edit it to suit what I'm about to do. So I can either increase the exposure or what, decrease the exposure for it to look a little bit what, bright, right? So I'm done with this one. I'll not touch this one. This one is image-based lighting, sharp highlight. We have soft, we have warm. This one I'll not talk about. I'll leave it for the advanced people. Now we are done with the environment. Now left with one thing. You see this small arrow here? We'll click on it. It also opens a new environment window. We are come to set our render. We want it extremely high quality. We don't want any distortion in the artifact we are about to render, right? So what do? We want to render the window. Now this means the window. This whole thing you see over here, where my mouse pointer is moving, this whole thing, the whole screen you see is the window. I want it to look like exactly how the window is, or I can basically choose different one, but the viewport, that's when I'll use this side, or the region, I'll select a particular region to render. But I want to use window and the render size, right? This is the 1080p. You should know this. I'll leave it for the advanced class, but you should know this. Resolution, pixels. We have 1080p pixels or resolution. I want to go by the high pixels, right? So I mostly use, what do I mostly use? I use this 3300 pixels. 3300 pixels instead of the 1080p. So I select this pixel, current presets. I want the image to look high quality. Even some can render overnight, render for 12 hours. The more you are like, the more time you render the thing, right? The more the image becomes what, very clear and what, sharp. The more you get the image very clear, the more you render. So some people render their work overnight. When maybe when they're about to sleep, you just start rendering. Especially those who do the building drawings and architecture and other stuff. This designing thing, let me tell you one thing. It is very time intensive. It needs a lot of time, right? So some people really can render overnight to 12 hours. So assuming they are to design a house for you, they will render the front view 12 hours. They will render the end view 12 hours, and they will render the back view or whatever view they want to do 12 hours, 12 hours, 12 hours, just for the quality sake, right? And that's the main reason why designing is expensive. The actual designing is not difficult. The knowledge behind it is not difficult, but the time it takes or the time you invest in it, that makes the thing looks like the thing called designing, like it's very time consuming. So I want to use the high quality. So this one, it applies 10 rendering levels, and with the rendering levels, I'll not explain it for now. So you can also select onto what satisfactory. So you can leave it on until you are okay that the image you have rendered is what it is to, maybe it is okay for you, right? Okay. So I'm done with the whole thing here. I've selected my pixels. I'm just hoping it is this size. I'm just hoping, but I'm sure it is this size. Surely this size. So this is what's high and other stuff. Let me see whether the shadows will come. Ground shadows. Let's see whether it comes in the rendering. I don't use it at all. So after doing all these settings, what do? You select render to size. Don't show this again. Continue without. Okay. So now we have entered the rendering space. So my laptop, I'll boost my laptop. Okay, the shadow didn't come. The shadow didn't come. So I can close it and make the image. So you see the things we go through. I see the image is not what centered. I have to stop whatever I'm rendering and redo it again. Select no shadows. Zoom it very well like this. Now, okay, now I'm good to go. I'll select all right, so I'm rendering, right? So until this bar gets to 100%, we are not done rendering. You see, after all this, we are not done with rendering before. So you can see the thing is very bright, right? You can see the knot is very bright. Am I right?
Yeah, it's true.
It's very bright.
Yeah.
So we can reduce the brightness. So let us stop the rendering. You see how it's time wasting. This thing, it is not a joke. So I'll just increase the exposure. I have my standard exposure I use, which I've used in so many drawings. That's 8.5. That's my standard exposure I use personally, 8.5. I'll select the render again. Now I think the tone is okay. I think the tone is okay now. You see, the more the bar loads, right? The more it's like the pixel is changing. See, the more the bar loads, the more the pixel does or changes. So now let us wait for from 5 to 10 minutes. I don't know whether it's on some laptops, it won't permit you to open other softwares. Yeah, some laptops won't permit you to open other softwares. Because when you are rendering, it uses both. After you go online and search, it uses both the GPU and the CPU in your laptop. I'm using a GPU of RTX 3050, right, which is very high. So with this one, it can at most it should finish in 10 minutes time. But the first laptop I was using, sometimes I spend about 1 hour, 30 minutes, sometimes 30 minutes, sometimes 1 hour just to render one web, right? And I remember I used a MacBook 2022 do AutoCAD, and the MacBook used 2 hours to render. I was shocked. 2 hours to render. All right, so let me see whether I can quickly go through the Autodesk Inventor. Okay, I think it is allowing me to go to the Inventor. So let us start the notes at the Inventor so that we will also know how the Inventor also works, right? As we wait for the AutoCAD rendering to finish. Okay, so I'll select my parts like this. Okay. Because a lot of stuffs are going on with my laptop GPU, it will be a little bit slow. It will be a little bit slow because of what I'm doing, the rendering I'm doing. Okay, it will be a little bit slow, so please bear with me. But I can close for now. I can close the SolidWorks so that this is what I was talking about. It's either it won't allow me to open it because it uses a lot of GPU. Okay, so up to this point, any general question? Any general question? Any general question? Can you all hear me?
Oh, yeah, we can hear you. Can continue. We are following.
Yes, sir, we can hear you. You can continue.
Okay. It is slow because of the rendering I'm doing at the background. So I think when it is done, you see. So please advise yourself when you are not using a better laptop. Even with my laptop, look at what it is doing. I wanted to start the drawing. Okay, let me try and close. How do you call it? Then get can see. Proceed. Right. So I've closed the inventor, right? To avoid any problems. I'll close the inventor so that we can render it fast. You see, it is clear. You see, it's getting clear. It's getting clear. It's getting clearer. It's getting clearer. Getting clear. So 4 minutes here. So let's say another 4 minutes here and 2 minutes here. So basically 10 minutes, as I said. Let me boost my laptop. Let us wait for it to finish. I can equally save the image here and end it here. I can equally do that now. I just want it to finish. So I can sense the material they used here. The materials they used here was steel. I can sense they used steel. There is also a drawing. There is a real object that you can see. There is a V groove. That's a triangle. Okay. We could have even done ours like this. Put the knots aside them, but I just inserted them. I hope you guys are appreciating what we are doing.
Yeah, more appreciate.
This is what I showed to you guys first in the drawing. So with the type of boats, we even have the countersunk boats. We can draw the countersunk boats as well. Let's check the progress of our work in 6 minutes. think we have 4 minutes left for the rendering to finish. You see the way it is very smooth and clear now. See the way it is very smooth and clear now. Hello.
Yeah, we can see. You can see it's very clear.
Yeah, very smooth and clear. So as time goes on, it will be getting clearer. You can see some mirror. So this one, it is not magic. Simple ways. See, so the 10 minutes is up. So I think you have 2 minutes left.
It's simple, but seems complicated.
It seems complicated.
It seems to be complicated. It's not easy.
Really? Oh, it is very easy. Very, very, very easy.
Yeah, it is very, if you know how to do it.
You knowing how to do it is very easy.
Yeah, because I didn't just do it in one day. I didn't just do all this in one day, and I wasn't taught by anyone to. I didn't get the opportunity you have now. Yeah, I didn't get the opportunity you have. I learned everything by myself. Learned everything, doing researching online. When I don't understand anything, I go to YouTube. I read books. I follow people. I follow design people. I follow designing softwares. I'm very curious in knowing what this software does. Small, and I go to this, and it's never an easy task. Sacrificing my sleep, sacrificing a whole lot of things for this. You see, I sacrificed a lot. It's designing comes with sacrificing, because if you don't sacrifice your time, you can't.
Yeah.
You don't sacrifice your time, you can't do it. You see, when we started the class yesterday, I think almost 20 or more people joined. But the thing sounded boring, so they left. So it's all boils down to sacrificing your time. Do you get what I'm saying?
Yeah, but you see, the problem too. You see,
yeah, I'm listening.
You see, the problem too is from some of our areas. The network is not good. You understand?
Yeah.
Me, for instance, yesterday it was raining, so but you can't on your data to do anything online. You see, so yesterday meeting, for instance, just listen, I couldn't catch up with it because of the raining and
All right, so I said 12 minutes, right? And 12 minutes, some seconds, it's done. It was supposed to be 10 minutes, but I think it's delayed in 2 minutes because of the stuff I opened. So now my computer's fan is resting. So now I'm done and I can save this. So I press this save button over here. I want to save this as an image. I want to save it on my desktop and name it Bolt and Nut. Bolt and Nut. PNG, yes. I want to save this file as PNG. I can do the JPEG format, but I want to save this as PNG. I'll save it. This one, make sure you select what? 32 bits. 24 bits plus alpha. All right. Make sure everything, the settings is like this. It has its own reasons. You just press your save. You are done. Now let us view what we just saved. We have this desktop. And this is what we did. This is the outcome of what we drew. Very nice. Very, very nice. Right? Very nice and was realistic. Though we didn't add so many details to it. Sorry. We didn't add so many details to it. Very nice and realistic. Very nice. You see the reflections and a whole lot of stuff. Very nice. Very, very nice. So assuming you have a whole machine. You have a whole machine. You can do it. A whole machine to draw. You can do it. Very nice. Okay. So let us move to the inventor. Let me skip this one. So even with the material, you can select wood. Let me show you guys. Wood. So let me select this. Select this. You see, it looks wooden. Wood. Can apply the wood. It will look real after rendering it. It will look real wood. It will look like a real wood, right? Look like a real wood. So a whole, so on and so forth. Right. Please, can I ask a question? How many of you here have heard of forex trading? Forex trading.
Yeah. I've heard of it, but I don't have much idea about it.
Oh yeah,
Really?
like me.
Okay, I'll invite someone to.
I've been reading them with it.
Yeah.
Yeah.
Okay. Then we'll have a guest online. He's a forex guru.
Oh, okay.
Yeah, we are partners.
Okay,
I'll
nice.
invite him. So the last 10 minutes will be used.
Looking for men.
Oh yeah. So we'll use the last 10 minutes for that. Okay.
Looking for a tonto.
All right. So let me open my AutoCAD Inventor app software. Let us continue. All right. So I'll move very fast. You see, because I'm done with the AutoCAD rendering, it came very fast. So this one too, I want to do what? Draw my polygon. So I'll select the start sketch, select the plane. Yesterday, Friday, I talked about the plane. So let us use the ground plane for now. I'll select my polygon, type 3 size, everything. With this one, the truth about it is you don't type. It is there. You see, it is different. The person who is the person who asked the question that is AutoCAD and Autodesk Inventor the same. Please, are you still active? Unmute and talk to me.
Yeah, I'm active. I'm active.
So you are focusing. So with the AutoCAD app, we had to type the whatever size. So this is basically inscribed, and this is what circumscribed. Right. So you want to use the inscribed method. So you're not pressing anything.
Okay.
Let me start again. When you click on polygon, you're not pressing anything. No enter, nothing. The moment you click on polygon, you start drawing. So I'll start from this center like this. I'll draw to any dimension I want, because later I'll do what? I'll give it proper dimension. I'll press down like this. Now I have it like this. Right? Now I want to constrain it. I want to make it stand very well. So I just press this and now it is straight. This is the constraint. This is the vertical constraint. We have the vertical constraint, horizontal constraint, and the tangent constraint. Right? So I'll just click my dimension like this. We want it to be what? 20, right? Like we used for the other one. The thing is missing, so I'll just click here because of the large dimension. This one, I didn't adjust the working area like I did for the AutoCAD. So it will only help me adjust by pressing this portion over here. This is what you'll be doing in school. If you're in level 200, next semester, this is what you'll be doing. So please pay attention. So now we are done with the polygon. With this one, we are not going to draw any circle. We are not going to use what? Any fillet. We'll just finish our sketch like this. It is missing again. I'll just click the other side. It will come back. And with this one, we are going to use, there's no press pull in Inventor. We have something we call what? We call extrude. This is the extrude. The height we use 20, so we use 20 here too. And 20 there, effect. Let us use 15. Okay, for it to look real, let us use 15. Now we are done with the 15. You press enter like this, right? Now I'll select this face again. I'll select start sketch at this face. I'll select my circle from this center. I'll put it out to this tangent. That's the end of the polygon or the hexagon. I'll just press OK, right? I'll just press extrude again. Now with this extrude, I'll not type anything. I'll just select flipped at the boolean area. Okay, no, this is the boolean, so I'll just select the direction flipped like this. And I'll just select what? Intersect. Now the taper. Now that's when the degrees come inside. The taper is where I'll type what? My 45 degrees. Like this. Right? Simple. And I'll just press OK. So looking at this method and the AutoCAD method, which one is complicated? I'm listening
The
to you
AutoCAD
guys.
is complicated.
Yes, but I prefer the AutoCAD in drawing than the Inventor. I don't know why, but I feel the AutoCAD.
My Autodesk Inventor is 2025, but since there's some changes here.
Yes, there'll be some changes.
Yeah, you need to use the old one.
I'll advise you guys. I'll advise you guys to, as beginners, right? I'll advise you guys to use older versions of softwares like this, so that when you find any problem in designing and you go online, you can follow their steps or what procedure. Assuming you're using 2025 version, but you want to draw a thread, and you go on YouTube and type how to draw a thread on AutoCAD Inventor, you will not get the new versions, and you'll find yourself wanting with the kind of commands they'll be using, because it will be different. It might be the same, but it will be different. Do you get what I'm saying?
Yeah, I get it. But like I was downloading it, I get the new up. I couldn't get the old update. That's why.
I understand. I understand. Don't download it on their official website. Go to Get Into PC.
Yeah,
and download it. And download it. So I'll select this face, right? Start a sketch at this face. Pick my circle to locate my center and draw it to touch it. That will be my tangent for now. I'll just rotate it like this. Select my extrude. Flip it to the other direction. Select the intersect like we selected for the AutoCAD. We will type the angle 45. Press OK. We are done. I can select this face again. Create what? New sketch. Press my circle. Select my circle. We selected 10, right? 10 like this. Press enter. Extrude and flip it to the other side. Cut. It is already cut. We have join cut. I'll cut it. Now I've cut through. So Inventor is simple. Now let me see whether I can chamfer this edge. I'll just click on it and I'll just select create chamfer. I'll just type in the chamfer I want to create. Assuming I want to create no, 2 is too much, so let's say 0.5 chamfer. Now apply it like this. I'll select this side to the same chamfer 0.5 apply. Okay, like this for it to look real. Now I can let me see. Okay, let me see the origin and see what I can create. I don't want to waste my time. Come to advanced class. You understand? I wanted to create the threads in it so that it will look realistic. So now we are done. The inventor, that's all. We are done with our notes. The inventor, you can select the view and other stuffs. The material add in inventor, you can automatically add material without going anywhere. So let's add the material. You just come to this top here, the default, you just change it to, let's say you want to use I didn't select it. Still polished, right? You see, still nice, still like this, shining like this. Now I can select view, environment, view, visual style. I'll select realistic for it to look what? Realistic. Now the inventor, it comes with a whole lot of, when rendering, right? You see the lights, there is light, right? There's light at the center. You can see there's light at the center. So I can toggle on my shadows. Now you see the shadow. You see the shadows. I can toggle on reflections. You see the reflection to the ground. I can toggle ray tracing. Ray tracing, I'll toggle it on later. I'll select high like this. You see, so anywhere I go, it will follow the tracing. Okay, so let me disable it for now. Let me disable the ray tracing so that I can easily render it for you guys to see. So I'll select my environment. Let me do the ray tracing for the work to look nice. When you do the ray tracing, the work looks nice. I hope you are following. I hope you are following.
Yeah.
Okay, so
Following.
let me forward the link to my guy so that. All right, so the ray tracing is done. Let me select my environment. Now I can render image. I'll select my, why is it disabling my ray tracing?
Please, can you go back a bit fast?
Okay. All right. I think this material is not nice. It's not suited to me. Let me select polish brushed. No, it's also not nice. Galvanized.
Yeah, this is okay.
This is okay. Yeah. This is okay.
Oh, yeah.
It's okay. So I'll select environment, right? I'll select environment. I'll finish Inventor Studio. Press finish. You come to Inventor Studio again. You select what? Render image. These are a whole lot. This one, the Inventor, it has a whole lot of features, Papa. We have studio lighting. You can change the lighting style. You can change a whole lot of things. You can even do an animations over here. So I'll select the render image like this. The aspect ratio, since they are not high resolution, blah 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 over here, I'll just select the highest pixels. That's the 1080p. The camera current view, yes. Log aspect ratio, blah blah blah. And I'll make sure it is here. The thing is here like this. I'll just select render. Right? So like how the AutoCAD did. It's this one also does the same. You see, but this one it flows faster. But with this one, I can render and render all over again. Render till I'm satisfied with the quality I want. You see, I told you this one, you see the reflections over here. It's almost the same as this. This ones I was talking about. It's almost the same as this. You see the reflections. You see the reflections. It is almost the same. So now it is done. So I'll just press continue rendering again because it's not clear to my liking. It's not clear to my liking. I hope you guys have learned a lot.
Sure.
Yeah, because a lot of things are mentioned over here. They don't teach. We don't do that during lectures. You have to, especially with the rendering aspects, you have to do it yourself. All right, it is done. Let me do the last rendering again, meaning I've done it 3 times for me to get a clear picture. All right, so it is done. So we just press our save over here and we save it desktop. Desktop. These are part 1 because we selected the part from. We just press our save. Now it has been saved on our desktop. Let's see. So this is the AutoCAD view and this is the Inventor view. Very nice. Which software do you guys prefer most? Which software?
The Autodesk Inventor.
You prefer the Autodesk Inventor?
Hey.
Why do you prefer the Autodesk Inventor?
Because it looks very simple.
Advanced, yeah.
level are you guys? The one saying no to this inventor. Which level are you guys?
200.
Level 200. We are the coded schools.
You're in level 200.
Yeah.
Oh, okay.
I was the
And
guy
so-
who came to you at the office.
So you are yet to do the AutoCAD, right? The computer aided design.
Yeah.
I was the
Yeah,
guy you
yeah,
saw
yeah.
the inventor for my laptop.
Yeah. I understand. Okay. So I think that's it. That's the class.
Okay.
Thanks for having you guys, and please the host will join soon. Please let us give him 5 minutes to also explore some other time. Hello, Latif, please, are you on?
Okay. Thank you very much, Joseph.
And please, I'm coming. Please don't go off. Don't go off. Please don't go off. Don't go off yet. Right? Don't go off yet.
Okay, we are waiting.
Yeah. All right, I'm chatting with him. I think. All right. So these are basically you see there's one part. I think let me try and cut the threads and see whether I can do it. So just be observing. So even with this, I can still work in this area, but it is not advisable working in areas like that with shadows and other stuff all around. Yeah, I don't like it. I like it raw like this. That I'll see the actual thing and I'll see what I'm doing. All right, someone has raised his hand. Any question? Any questions so far?
So, please, so meaning during the exam time too, the question will be printed, and then we will use either the AutoCAD or Autodesk Inventor to do whatever we are doing right now.
No, you are restricted to Inventor. You are restricted to Inventor.
Oh, okay. Meaning you can't use the AutoCAD.
Or you can't use AutoCAD. You are restricted to Inventor.
So during the exams, how is that?
Exams.
Are you on the laptop or
More PowerPoint too much. More PowerPoint too much. More PowerPoint too much.
we are the coded school, so we have to know.
More PowerPoint too much.
We are the coders.
Oh yeah, no need. So what GT na kind of tire maybe our left side. I go for maybe so vibration and the vibrate to on left side. Say right side tire no go for maybe so the vibrate to right side. So vibration on all sides. And this is what I need pipe the whole part and vibrate to them. Maybe I kind of slice maybe I say we'll shoot but I'll make we shooting. So I pass never vibrate. I don't mind.
All right. Oh, please don't go. Don't. People are leaving. Who is the guy who said he needs this thing? The mentor.
All of us,
Yeah,
all of us.
we.
All of you guys. All right,
Yeah,
so
yeah.
I'm
We need a
sending.
mentor. Yeah.
So I'm sending the link right in the group. But don't leave. He's coming. He's coming. He's a very busy guy.
Yeah, we're not leaving because we are not going to do anything. We are here to learn.
Yeah.
All right, let me send the link to the channel, Telegram channel right now, so that you join. Okay, the link is in now. All right, the link is there now. The link is there now. So you can join us. You are still waiting. You can join. You can troop in. You can troop in. 1, 2, 3, 4. I want to see the four of you there. I want to see the 4 of you in the channel right now. I want to see the 4 of you in the channel right now.
You will see us there. You must see us there.
Yeah, I've sent you the link. I hope you've seen the link.
Yeah, I've joined.
Nice. Okay, let me end the recording.
You send the link on the group or
Yeah, I sent the link
on that one.
Yeah, I sent the link to his platform.